Alright, so in this lecture, we're going to be finding the moment of inertia about the center of mass of our region that we covered in the last video. So we have the region y equals x bounded by -1 to 1/2 in terms of x values, and it's bounded by y equals x and y equals 2x squared minus 1, and it has a density of x squared. Our centers of mass ended up being 4/7, 1049, or 4/7 for x and then 1049 for y. And so we want to find the moment of inertia about our center of mass. And we can do this by adding our moment of inertia about our x bar value plus our moment of inertia about our y bar value. And this comes from the parallel axis there. But in order to do this, we actually need to find a moment of inertia about our x value and about our y value. And so for our x bar, we think of x is equal to 4/7. So if x is equal to 4/7, and this isn't exact, but if x is equal to 4/7, this is just a translation of the y-axis over 2 units. So we have the integral. And also, let's just, for general sake and rewriting this, moment of inertia is equal to mass times the radius from the axis of revolution to the point of mass squared. So, alrighty. If we think about this axis to any point within the region, or its parallel distance, it's just going to be whatever x value we're at subtracted from 4/7. So it's going to be x minus 4/7 squared, and then dm. Alrighty. And keep in mind, this is going to be a dm strip. And I'm sorry, I accidentally wrote this over the wrong thing. I believe I said the right thing, but I'm not sure, so just in case, x bar is going to be the 4/7 value, and it is going to be an x value, like I drew up there. But now, we need to figure out what our dm strip is. And I'm going to erase our little dx right there for the time being. And now, still we have our 8/7 line, our 4/7 line. Well, we're going to draw a little bitty point, which has a width, and we're talking about just this little point, colored in point right here. It has a width of dx and a height of dy. And we're going to call this dA of point. and it's going to be dy dx. Alrighty, and then our dm of a point is going to be x squared dy dx. And now this is dm of a point. Remember that dm of a point is, or the integral of dm of a point over a region is going to be equal to our dm strip, which is what we want to actually find. And this is because we're going to effectively either add a whole bunch of boxes over a region to form a dm strip this way, or by integrating it from the top function to the bottom function, or we're going to integrate it from left to right of the region, forming a horizontal vertical strip from the left function to the right function. So if we are wanting to find the moment of inertia about our x value, we're going to want to integrate this from the top function to the bottom function. So we're going to integrate dmt is equal to the integral of x squared dy dx, and we're going to want to integrate it from the bottom function to the top function. So this is from 2x squared minus 1 to x. And we're going to want to integrate this with respect to y, because our x is going to remain constant, because we're only looking at this little x value strip. So our dm strip is going to be equal to the integral from, x squared dx times the integral from 2x squared minus 1 to x of 1 dy. It's going to be equal to x squared dx times y evaluated from x to, or from 2x squared minus 1 to x, which is equal to x squared x times x minus 2x squared minus 1 dx. Alrighty, so moment of inertia about the x-axis is going to be equal to integral, and then this is going to be in terms of x, so it's going to be from negative 1/2 to 1 of x minus 4/7 squared times x squared we'll actually go ahead and multiply out our x squared, so this turns into x cubed minus 2x to the 4th minus x squared dx. And that is the setup for a moment of inertia about the x-axis, and we'll also go ahead and do the setup for the moment of inertia about the y-axis, and then we'll go ahead and solve for both of them. Alrighty, so now this was for our x bar. For our y bar, we're going to do things a little bit differently. We're going to want to integrate our little dA of a point, dy is equal, or sorry, dA of the point is equal to dy dx. That brings us to dm of the point is equal to, we'll actually look a little bit at our function for this. We'll be daisy. Had some writing left over from earlier, although we're about to take a look at that. So in this case, we have our point with a width of dy, with a height of dy, a width of dx. We're going to want to form a horizontal strip, because now we're cutting our region into little horizontal strips, so we can have, right, we have our axis, which is at 1049, which we'll just call right there, and our radius is going to be a y distance squared. So we're going to want little horizontal strips, and to form those horizontal strips, we have to integrate our little dA point from our left function to our right function. So our left function is y equals x, and it solves for both variables. But I also want to consider, now we're looking at, let's talk about this for a little bit. We're going to talk, or we're integrating from left to right, not from up to, or not from bottom to top. So we're going to integrate with respect to x, which means we need to have our functions in terms of y. So, right, our second function, our right function, is going to be y is equal to 2x squared minus 1. Which, whenever we solve this for y, we get y plus 1 over 2 to the 1/2 is equal to x. We also have to remember this is going to be plus or minus 1/2, because whenever we take the square root of something, it has a positive and a negative half. And because of how symmetry works, we also understand that pretty much for each x value or for each y value that we put in, we're going to get a positive and a negative value, which works kind of like that. It's going to be a symmetrical value about the y-axis. So this is going to be our positive function, and this is going to be our negative function. Well, in order to integrate and form our little strips, we're going to have to integrate across our region, and it's going to have to go across our region everywhere, including places like this, which is pretty much where our left and our right function are actually going to be the exact same function. The question that we have is, or they're not going to be the exact same function, but the function on the left-hand side is going to be different depending on what y value we're at. So what we have to recognize is that right here where these functions interconnect, there's going to be two different integrals for dm. And so our first question that we have is, right, what region, or what is our total region that we're on? And in order to know that, we have to know a little bit about our functions. Well, we know whenever we plug in 0 for x, it's going to give us our minimum function, because our quadratic function is our lowest and it's centered about the x-axis, the y-axis. So we know that our lowest y value is going to be right here, and it's going to be -1. We also know that our point of intersection between the two functions right here is going to be at -1. So I'm sorry. It's going to be at -1/2. I got that switched around earlier, but it is all right. It's going to be at -1/2. So we know that our point of intersection is -1/2. And finally, we know our highest point is going to be that 1, which is also just going to have a y value of 1. So all right. I'm sorry, I accidentally went a little bit ahead of myself. The dm point is going to be our density function multiplied by dy dx, so it's just going to be x squared dy dx. And then we have our dm strip, which is going to be equal to the integral of x squared dy dx. And then what we just talked about is going to be what changes that integral around a little bit. Alrighty, so let's think about this. Okay. In order to form this horizontal strip up here, we're going to have to integrate from our left function to our right function, which is from x to our quadratic function, which is y plus 1 over 2 to the 1/2, and that is dy, and that is our dm point. And that is for whenever y is going to be greater than -1/2. However, whenever y is whenever y is between -1 and -1/2, our left function is actually going to be our negative quadratic function. So negative square root of y plus 1 over 2. And our right function is going to be y plus 1 over 2. And so whenever y is between, and sorry, there also is a top region on this, but it doesn't truly matter. It's going to be up to 1. And so whenever y is less than -1/2, but it's greater than -1, it's going to be the integral from negative square root of y plus 1 over 2 to square root of y plus 1 over 2 of our dm point. All right, so now, and we'll simplify this. So we'll say whenever y is greater than -1/2, it is the integral from y to square root of y plus 1 over 2. And then that's going to be x dx multiplied by dy. And then whenever y is less than -1/2, we have dy times the integral from negative y plus 2 over 1. Sorry, y plus 1 over 2 to positive y plus 1 over 2. And this is of x dx. So, alrighty. Now I have our mass strip. And we can go ahead and integrate this. So this turns into, I'm sorry, I did miss a square. It's going to be x squared, and that's going to be x squared. So this is going to turn into dy times x cubed over 3, evaluated from square root of y plus 2 over, or y plus 1 over 2 to y, which is now going to be dy times, this is all over 3, y plus 1 over 2 to 3 halves minus y cubed. And then over here, we're going to have the exact same antiderivative, except this time it's going to be evaluated from the same top bound, but the different left-hand bound. So it's going to be dy times over 3, y plus 1 over 2, 3 over 2, minus, and then this is going to be negative y plus 1 over 2. That's going to be cubed. Well, and that can be simplified a little bit into dy. Our negative can be brought out of the cube, because whenever you have a negative thing cubed, it is still negative. So, and then the negative becomes a positive. So the two things get added together. So it becomes 2 times y plus 1 over 2 to 3 over 2. That's going to be divided all by 3. Alrighty. So we have 2 DM strips. They're just based on different times, or different y values. Alrighty? And so now, as we talked about earlier, our radius from a parallel axis is just going to be the distance between 10 over 49 to each different y value, which can be written as y minus 10 over 49, and that's going to be squared because of our general moment equation. So it's going to be y minus 10 over 49 squared. It's going to be multiplied by our DMT. And so in order to write our DMT down, we're going to actually have to go ahead and separate our integral into 2 different bounds. So we're going to have from -1 to -1/2. And this is going to be from whenever y is less than 1/2. So it's going to be 2 times y plus 1 over 2 to the 3 halves. And then that's going to be all divided by 3. And then dy goes at the end. And then this is going to be, now we're also going to go ahead and add the integral from -1/2 to 1 of y minus 10 over 49 squared times y plus 1 over 2 to the 3 halves minus y cubed all over 3 dy. And so, that is both of our setups for our moment of inertia about our centers of mass. Alrighty. So we'll go ahead and do the moment of about the x-axis first. So we have x bar, moment about the x-axis, or about our x center of the mass is equal to integral from -1/2 to 1 of x minus 4/7 squared times x cubed minus 2x to the 4th minus x squared dx. We'll make sure that we wrote that down properly from earlier. Yep, we did. Oops. And we actually did make a little bit of a sign error right here earlier. So that should be negative 2x squared plus x squared. Sorry about that. Be plus x squared. Alrighty. Now we'll go ahead and square out our first term. So 1/2 is x squared minus 8/7 x plus 16 over 49. This is multiplied by x cubed minus 2x to the 4th plus x squared dx. And now we can go ahead and multiply these out. So we have x to the 5th minus 2x to the 6th plus x to the 4th. And now we have minus 8/7 x to the 4th minus 16/7, plus 16/7 x to the 5th and minus 8/7 x cubed. Now we have plus 16 over 49 x cubed minus 32 over 49 x to the 4th plus 16 over 49 x squared dx. Alrighty. And now we can start combining the like terms. So we have from 1 to -1/2. And we'll start with our x to the 6th term. So we have negative 2x to the 6th. That is all our x to the 6th term. So negative 2x to the 6th. X to the 5th terms, we have a positive x to the 5th. We have a positive 16 over 7x to the 5th. And that will be it for x to the 5th term. So we have 23 over 7x to the 5th. Now we have our x to the 4th terms. So we have positive x to the 4th minus 8/7 x to the 4th minus 32 over 49 x to the 4th. So we'll just simplify this and write this as negative 1 over 7 x to the 4th minus 32 over 49 x to the fourth. And we can simplify that a little bit more and say that since those are, or we can simplify that fraction even more and say that this is negative 7 over 49. So that becomes negative 39 over 49 x to the fourth. Alrighty, and then we have our x cubed term. So we have a negative 8/7 x cubed. We have a plus 16 over 49 x cubed. So that is going to be negative 56 over 49 plus 16, which is negative 40 over 49. X cubed. And now finally we have just our x squared terms, which is only one term, so plus 16 over 49 x squared. So this dx. And now we can actually go ahead and integrate. And we have negative 1/3, or sorry, not negative 1/3, negative 2 over 7 x to the 7th plus 23 over 7 times x to the 6th over 6 minus 39 over 49 times x to the 5th over 5 minus 40 over 49 x to the 4th over 4 plus 16 over 49 times x cubed over 3. And these are all evaluated from negative 1/2 to 1. Oops. And I have the integral symbol on accident. Oops. Alrighty, so now we can go ahead and plug these in. So we have negative 2/7 plus 23 over 7 times 1/6 minus 39 over 49 times 1/5 minus 40 over 49 times 1/4 plus 16 over 49 times 1/3. I have minus negative 2/7 times negative 1/2 to the 7th plus 23 over 7 times negative 1/2 to the 6th over 6 minus 39 over 49 negative 1/2 to the 5th over 5 minus 40 over 49 negative 1/2 to the 4th over 4 plus 16 over 49 times negative 1/2 cubed over 3. and this is in bracket. And now we can go ahead and go through and distribute our minus. So we have this turns into plus, this turns into a plus, this turns into a minus, this turns into a plus, this turns into a plus, this turns into a minus. We flip all of our signs. And now we can go ahead and plug this directly into our calculators. And for this, we end up getting 81 over 4,408. And that is equal to our moment of inertia about the x-axis. Or about our x value for center of mass. So now we need to go ahead and do our y value. So we have I sub y is equal to two integrals. Oopsie daisy. So I sub y is equal to the integral from -1 to -1/2 of y minus 10 over 49 squared times 2 times y plus 1 over 2 to the 3/2 over all over 3 plus the integral from -1/2 to 1 of y minus 10 over 49 square all squared times y plus 1 over 2 to the 3/2 minus y cubed all over 3. And that's also with respect to y. So what we're going to do is we're actually just going to go ahead and solve these integrals independently. So we'll solve our left integral first, so -1 to -1/2 of y minus 10 over 49 squared times 2 times our 2/3, we'll go ahead and pull the 2/3 out, times y plus 1 over 2 to the 3/2 dy. Alright, so we have a 2/3 in the center, so we'll go ahead and pull that out. So we'll have 2/3, -1 to -1/2. And then we'll go ahead and square out our first term. So we have y squared minus 20 over 49 y plus 100 over 49 squared. And now this is multiplied by 2/3, or not 2/3, y plus 1 over 2 to the 3/2. And so what we're going to go ahead and do is create a u substitution. So we're going to say u is equal to y plus 1 over 2. Alrighty. And then we get du is equal to 1/2 dy. So 2 du is equal to dy. And then now we get 4/3 integral from -1 to -1/2 times y squared minus 20 over 49 y plus 100 over 49 squared times u to the 3 halves du. And now we actually need to do a second substitution and sub in u for all y values. So we can actually rewrite that up here. So we have u is equal to y plus 1 over 2. So this becomes 2u is equal to y plus 1. And then it becomes 2u minus 1 is equal to y. So we're going to plug in 2u minus 1 for all of our y values. So we have 4/3 was the integral. And I'm sorry, we forgot to rewrite our bounds earlier because now we've changed what we're integrating with respect to. So we had negative 1/2 as our top bound. Alrighty. So whenever we plug in negative 1/2 for y, it becomes 1 minus 1/2, which is 1/2 over 2. So that becomes 1/4. When we plug in negative 1, it becomes 0. So from 0 to 1/4. And now we can go ahead and do what we were doing just a second ago and plug in all of our y values. So we have 2u minus 1 squared minus 20 over 49 times 2u minus 1 plus 100 over 49 squared, all times u to the 3 halves. Alrighty. And what I would do from here is go ahead and split this into 3 separate integrals. So it would be a little bit easier to do each individual term, or you can keep it all in one integral. But just in case, we'll separate it into 3 separate integrals just to make it a little bit easier. So we have 0 to 1/4 of 2u minus 1 squared times u to the 3 halves minus integral from 0 to 1/4 of 2u minus 1 times u to the 3 halves plus integral from 0 to 1/4 of, and this is a constant multiplier, so we can bring it outside, 100 over 49 squared times integral from 0 to 1/4 of u to the 3 halves du. And all these are with respect to u, of course. Alrighty. And so this is equal to, we'll go ahead and multiply out our 2u minus 1 squared, so this becomes 4u squared minus 4u plus 1. I'll multiply by u to the 3 over 2 minus integral of 2u to the 5 halves minus u to the 3 halves, 0 to 1/4 du, plus 100 over 49 squared times integral from 0 to 1/4 of u to the 3 halves And now we can go ahead and multiply out our first integral. And this becomes 4 times u to the 7/2 minus 4u to the 5/2 plus 1, or plus u to the 3/2. And then we'll actually go ahead and write this as one big integral again, just so we can combine like terms and do some things before we go ahead and integrate out. So this will be minus 2u to the 5/2 plus u to the 3/2 and then plus 100 over 49 u to the 3/2. So all with respect to u. And so now we can go ahead and combine like terms. Alrighty, so now we have 4/3 times the integral from 0 to 1/4, and we're going to combine some like terms. So we have u to the 7/2, which doesn't have any like exponents, and then we have negative 5/2. Well, we do have negative 4u to the 5/2, negative 2u to the 5/2, so that becomes negative 6u to the 5/2. Alrighty, and then now we have u to the 3/2, so we have 2u to the 3/2, u to the 3/2 plus u to the 3/2, and plus 100 over 49 squared u to the 3/2. So we have 2u to the 3/2 plus 100 over 49 squared u to the 3/2. Alrighty, and so we can actually combine these terms, and thus it turns into 4,902 over 2,401 u to the 3/2. And this is all integrated with respect to du. So now we can actually go ahead and find our antiderivative. So we have 4/3 times u to the 9/2, or times 2/9 u to the 9/2. Whoops. And then we have minus 6 times u to the 7/2 times 2/7 plus 4,902 over 2,401 times 2/5 u to the 5/2. This is evaluated from 0 to 1/4. Alrighty. So now we can actually go ahead and write this out. So we have 4/3 times 2/9 times 1/4 to the 9/2 minus, and we'll go ahead and simplify our fractions a little bit. So minus 12 over 7 1/4 to the 7/2 plus 4,902 over 2,401 times 2/5, 1/4 to the 5/2. And then minus, and then actually 0 is going to eliminate all of our terms because all of our terms have a u in it, and whenever we plug in u for any of the terms, it's just going to equal 0, which turns into 0 multiplied by a constant. So we don't have any last half terms. So now we can go ahead and plug this expression into our calculator. And we will get the following. Alrighty. And so even when we plug this into our calculator, it does not give us an exact answer, but that is okay. We're just going to round to the first 5 decimal places. So we have 0.0166749. And then the next term is 0, so we round down. So, I'm sorry, first 6 decimal places. And that is the first half of our integral. Or that is our first integral solved. Alrighty. Now we will solve first, second integral. So we have, we'll bring this right over here. Integral from -1/2 to 1 of y minus 10/49 squared times y plus 1/2 to the 3/2 minus y cubed and this is all over 3. Alright, so we get 1/3 times the integral from -1/2 to 1, and we can go ahead and square out our terms just like we did in the original expression. And we get y squared minus 20/49 plus 100/49 squared. And this is times y plus 1/2 to the 3/2 minus y cubed. Alrighty. And in this case, it actually is going to be a little bit easier to separate this into two integrals. So we have 1/3 times -1/2 to 1 of, and for this one we'll do y plus 1 to y plus 1/2 to the 3/2 times y squared minus 20 over y, or 20y/49 plus 100/49 squared. And then we'll do minus the integral, and that's also with respect to y, from -1/2 to 1 of y, or y cubed times all those values, so this will become y to the 5th minus 20 y to the 4th over 49 plus 100/49 squared y to the 3rd. So with respect to y, alrighty. And so the second part of our integral is actually already integratable, so we have y to the 6 over 6 minus 20y to the 5th over 5, which becomes 4y to the 5th over 49, plus 25 over 49 squared, y to the 4th. This is all evaluated from negative 1/2 to 1. We'll put y equals negative 1/2 to 1. Alrighty. That's the first half of our integral done. For the second part, we're going to do a u substitution just like we did in the first problem. So, you guys remember whenever we do our u sub, and then you guys remember whenever we had our u sub, we just had y plus 1 to the 3, or we had, if we look at our original integral, we had 2 times our integral. So the 2 went out front. And so did the 1/3. But aside from that, it was the same exact integral that we just had, just only half of it. Right, we had the same exact terms in this part of our equation, just without the multiplier out front. So we have y squared minus 20 over 49 y plus 100 over 49 squared, all times y plus 1 over 2. If you go look at our integral over here, what we have now, we do have y plus 1 over 2 to the 3/2 times y squared minus 20 over 49 plus 100 over 49 squared dy. So now we know that we can do our u substitution, and we can plug in exactly what we got earlier. So we have 1/3 times and we'll go ahead and we'll do the u sub, not directly, we're not going to go through the whole entire thing again. But we know that it results in 2 times the integral from 0 to 1/4 of this integral. Alrighty. And so now we can go ahead and write this out just like we did earlier. So we get 1/3 times 2 times our 2/9 u to the 9/2 minus 6 u to the 7/2 times 2/7 plus 4,902 2,401 times 2/5 u to the 5/2. This is evaluated from u is equal to 0. U is equal to 1/4. And now this is going to be subtracted y to the 6th over 6 minus 4y to the 5th over 49 plus 25 y to the 4th over 49 squared, evaluated from y is equal to 1/2 to 1. We're going to just go ahead and switch the signs on our integral, or distribute out this. So this becomes negative y to the 6th over 6 plus 4y to the 5th over 49 minus 25 y to the 4th over 492. Or over 49 squared, sorry. Not 492. Alrighty. And now, whenever we multiply this integral out over here, we realize that it's just 2/3 times 2/9 e to the 9/2 minus 6 e to the 7/2 times 2/7 plus 4,902 or 2,401 times 2/5 e to the 5/2. Varied from u is equal to 0. Oh, I'm sorry. Our bounds aren't quite the same. I misspoke earlier because I forgot to plug back in our bounds into our u equation. So, right, we have u is equal to y plus 1 over 2. And our original bounds were from negative 1/2. So when we're plugging negative 1/2, just like before, we're going to get 1/4. And whenever we plug in 1, we get 1. So this is going to be from 1/4 to 1. So we have from 1/4 to 1. We have from 1/4 to 1. Alright. So we have from 1/4 to 1. So now we have the correct bounds in our integral. I'm sorry about that. Now we have plus 1/3 y to the 6th over 6 plus 4 y to the 5th over 49 minus 25 y to the 4th over 49 squared. It's evaluated from negative 1/2 all the way up to 1. Alrighty. And now we can go ahead and solve. So we have 2/3 times 2/9 minus 12 over 7 plus 4,902 over 24 times 2/5 minus our 1/4 value. And keep in mind, we already solved for this last time because our whole entire value was just our 1/4 value multiplied by 4/3. So if we multiply this value by 3/4 is equal to our direct use of value, our direct integration value. So we're going to do a little shortcut and do that. So I have 0.016749 times 3/4. And we get minus 0.0125617 or 18. Alright. And so that does give us a little bit of a rounding area, but we just want to have our answer to the third decimal place. So as long as we include enough significant digits, we will be fine. Alright. So now that we have that value typed out, we're going to also go ahead and solve out our other expression. So we have 1/3 times -1/6 plus 4/49 minus 25/49 squared minus, in brackets, -1/2 to the 6th over 6, and this is also negative, plus 4 times -1/2 to the 5th over 49 minus 25/49 squared, -1/2 to the 4th. Alrighty. We're also going to go ahead and flip our signs in our bracket by trimming out the negative. Alrighty. And so now we can go ahead and plug this into our calculator and get a final value for our moment of inertia about our y value. Righty, and for this expression we get I sub y is equal to 0.0258616, and this is just part of our I sub y, so this integral. So we have our total I sub y is equal to 0.016749 plus 0.025816, and that brings our I sub y is equal to 0.016749 plus 0.0258616, which brings us to a moment of inertia about our y value is 0.0426106. And now I can use our moment of inertia formula. I sub the center of mass is equal to I sub our our moment of inertia about our x value plus our moment of inertia about our y value, percent of mass, and we get moment of inertia about the center of mass is equal to 0.0426106 plus the moment of inertia about our x, 81/4,480, And we can double check that value real quick. Yep, 81 there with that 4,480. Alrighty, and we're going to round to our first three decimal places that aren't a zero. Then we get our moment of inertia about the center of mass is equal to 0.0607. Alright, so that is how we find the moment of inertia about a center of mass of a region that is bounded by two functions and also has a density function along with it. Thank you all for watching.